Good afternoon, ma'am. My name is Reshma and I am from the CSC branch from the section of B section. Today, I am going to present an PPT on the unit of third from the advanced data structures and algorithm analysis. And its subject code is 23CSC 301. And I have chosen the topic is minimum cost spanning tree. So I am presenting the PPT on the topic minimum cost spanning tree. So we are entering into the first slide. Here outline. Outline means the subtopics which I am going to present in the PPT. So we'll have a brief idea upon by reading this. So first point is introduction, minimum cost spanning tree. What is Prim's algorithm and algorithm of it, and what is Kerskal's algorithm and its algorithm steps, and next will be advantages and conclusion. So I'm going to first thing is introduction. Minimum cost spanning tree, which is known as in short form MST. It's a tree that connects all the vertices in a graph with the minimum total edge weight. So here MST is of two types. First one will be prims and second one will be Kerskal's. So we are going to know about these two types. So first one is Prim's algorithm. What is Prim's algorithm? Here I have given the definition of Prim's. Prim's algorithm is a greedy algorithm used to find the minimum spanning tree MST of a connected weighted graph. It starts from an arbitrary vertex and grows the MST by repeatedly adding the smallest edge that connects a vertex in the tree to a vertex outside the tree. Process continues until all the vertices are included in the MST. So we have known the definition. Moving to its algorithm steps. Prim's algorithm is another greedy algorithm used to find minimum span costing t. I have said in previous definition thing. So here I have presented a step-by-step process to know about keenly about the Prim's algorithm. So the first step will be initialize. Start with a single vertex, marking it as part of the MST. Keep track of the total cost of the MST and list out all the vertices included in it. Second thing is select the edge. From the vertices included in the MST, select the edge with the smallest weight that connects the vertex not yet in the included MST. So third step will be add edge and vertex. Add the selected edge and the connected vertex to the MST. Update the total cost and the list of vertices in the MST. So fourth step will be the repeat. So previously I have mentioned three steps, right? So we are going to repeat the three steps in this fourth step, means repeatedly. Then fifth step will be final step. Complete. The algorithm finishes when all the vertices are included, yielding the MST with the minimum total edge. So we are going to next type. Second type is Kerskal's algorithm. This algorithm is also a greedy algorithm used to find the minimum spanning tree of a connected undirected graph. A minimum spanning tree is a subset of the edges of a graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. So moving to its algorithm steps. Here also I have mentioned the step-by-step process to calculate the Kerskal's algorithm is a popular method of finding the minimum spanning tree of a connected undirected graph. Here are the some steps involved in the algorithm. So first step is initialize. Create a forest. Means a set of trees. Forest equals to a set of trees where each vertex in the graph is a separate tree. Create an empty set to hold the edges of the minimum spanning tree. Sort of the edges will be the second step. Sort all the edges of the graph in a non-decreasing order of their weights. So third step will be select edges, iterate through the sorted edge list. For each edge, check if it forms a cycle using a union find data structure. So if it does not form a cycle, then add it to the MST. If it does forms a cycle, skip the edge. Here we can observe clearly this point, very important point. If it does not forms a cycle, we are going to add into the MST. If it forms a cycle, then we are going to skip the part. So fourth is termination. Stop when the MST contains edges. Where is the number of vertices in the graph? And fifth will be the output, the edges in the MST and the total weight of the MST. So next I have mentioned the images of Prims and Kerskal's. By seeing this example, we are going to know more about the two types of algorithms. So next thing is advantages of Prim's algorithm. Advantages of Prim's algorithm I have mentioned in 6 points. First point is efficient for dense graphs. Second point is good for network design. Third is flexible starting point. And fifth one is simple to implement. So then advantages of Kerskal's algorithm. Here also I have mentioned 6 advantages of this algorithm. Efficient for sparse graphs, easy to implement and handles disconnected graphs, does not need to start at a specific node. So we can start wherever we wish to start from any node. So does not need to start. So greedy approach selects the smallest edge first and leads to the optimal MST. So here is the conclusion of this minimum cost spanning tree. Minimum spanning trees (MSTs) plays a vital role in graph theory and various real-life applications. They connect all the vertices in a graph with the minimum total edge weight, ensuring efficiency and cost effectiveness. Key algorithms such as prims and curls provide efficient methods for finding MSTs, each tailored for specific scenarios. The applications of MSTs are extensive, ranging from telecommunications and transportation to clustering and resource allocation. So here is the conclusion of this, and thank you very much, ma'am.